So today we're going to talk about arc length. Arc length is something that you do in geometry, but you do it with degrees, and we're going to look at it with radians, and I'm going to show you how those two things are related. So we're going to come up with an arc length formula based on what we know about circles. So first of all, it says if theta is a central angle in the circle, so what makes it a central angle is that the vertex is at the center of the circle. We have radius r, then the length of the intercepted arc, this right here, is given by blank. All right, so let's set a proportion, something that we can totally understand. That arc length S is part of the entire circumference. Would you agree with that? And theta, that is related to S, is part of the whole way around, which is 2 pi radians. Okay, so part out of the whole, part out of the whole. So then when I cross multiply, I can multiply S times 2 pi, so S times 2 pi is going to equal C times theta. Okay. What is the circumference formula of a circle? 2 pi r. So instead of C, I'm going to put in 2 pi r. So I'm going to have S times 2 pi equals 2 pi r times theta. So at this point, if I just divide both sides by 2 pi, then those will cancel out, and I get that S is equal to r theta. Okay? That's your formula for arc length. S is equal to r theta. So I want to look real quick at the formula that you learned in geometry. You could learn it as a proportion, and really that's the way I would teach it if we were teaching it with degrees, but there is a formula that they give you in the textbooks and formula charts. I don't want you to write this down because I don't want it to confuse anything. I just want to show you what's happening here. So that one looks really simple. The geometry formula that you get is S equals theta over 360 times 2 pi r, which is not like completely terrible, but it is a lot worse than that, right? Don't write this down. Okay, just follow along. No writing down because I don't want to confuse anything. I could take this formula, and I don't know why they don't, but I could reduce it, right? If this is like it's over 1, then I can say 2 goes into 2 one time and goes into 360 180. Okay? So that gives me, that equals theta times pi times r over 180. And then if I rearrange this a little bit, I'm going to get S equals pi over 180 times theta times r. Okay? So pi over 180, that's what we use to convert from degrees to radians, right? So in geometry, because you're using 360 and you're using degrees, this formula basically just has the conversion built in. So if I put in a degree right here, this converts it, and I still get my r times theta. That's why it looks all weird. So even though you were in degrees, it was converting it to radians, and you didn't even know it. So that's why they look so different, because it depends on whether you're in degrees or radians. And so that's why this says where theta is measured in radians. This only works for radians. The other would be for your degrees. Okay? All right, so let's look at this. It says in a circle with radius 3 feet, and make sure you're using the radius. One of the biggest mistakes is if I gave you the diameter that you use that. I know you know the difference. Radius of 3 feet, angle measuring 5 pi 6. So I know that S is equal to r times theta. So the radius is 3 times theta, which is 5 pi 6. And it says to give it in the simplest form. So yes, I could multiply straight across and get 15 pi over 6, but I would really rather reduce first. So when I reduce, 3 goes into 3 once, goes into 6 twice. So S is equal to 5 pi halves. And what would the units look like on this? Would it be feet or feet squared? What are we looking for? We're looking for a length. So is it feet or feet squared? It's feet. Questions? Or not converted? We're good. Yeah. This is what we want. Okay. All right, so then you do number 2. So these are exact answers. They're not what I call your Home Depot answers. Because like if you needed a piece of wire that would wind around a circle, and you went in there and said, I need my length to be 11 pi over 2 inches, they're going to look at you like you're crazy, right? So if you actually needed that, then of course you would get the decimal and go with that, but we keep everything exact until we absolutely have to. Okay, we're good? Awesome, easy. All right, let's look at number 3. In a circle, an angle measuring 3 pi halves radians intercepts an arc length of 3 pi 8ths feet. Find the radius of the circle in the simplest form. So remember, our formula is S equals R theta. And we substitute in what we know. We know the arc length. That's 3 pi 8ths. That's equal to the radius, which we don't know, times the angle, which is 3 pi halves. Right? And then, what do I do to get R by itself? I'm going to divide by 3 pi halves, which is the same as multiplying by what? 2 over 3 pi. Okay. So I'm going to multiply 2 over 3 pi times 3 pi over 8, and that's equal to R. The 3 pi's cancel out, so I'm left with 2 over 8, which is 1/4 of a foot. Good? All right, so in number 4, it says an angle measuring 15 degrees intercepts an arc length of 2 pi thirds feet. Find the radius of the circle in the simplest form. Okay, so that's in degrees. We need to be working in radians. So I could use the conversion formula. If I wanted to convert that to radians, what do I multiply by? It's either 180 over pi or pi over 180. Which one would it be? Pi over 180. But we don't even have to do that much because we know that 30 degrees is how many radians? Pi 6ths. Okay? And then 15 degrees is half of 30, so think before you speak. What is half of pi 6ths? Pi 12ths. So there is your angle. You finish that up. Look at 8 feet. Yes? Questions? Alrighty. In a circle with radius 9 meters, an angle intercepts an arc length of 6 pi meters. Find the angle in radians in the simplest form. Alright, so we have the arc length. It is 6 pi. That's equal to R, which is 9, times theta, which we don't know. So what do? Divide by 9. So I divide both sides by 9, and that will give me that theta is equal to 2 pi thirds radians. We good? Alrighty, then you do number 6. dividing by 18 is the same as multiplying by what? 1/18, exactly. What questions do you have? Anything? All good? We get 3 pi-4ths? All right. So let's look at number 7. It says the merry-go-round rotates 2,808 degrees per ride. How far would a rider seated 8 feet from the center of the merry-go-round travel during the ride? Okay, so first thing is we need this in radians, not in degrees. And we're not going to be able to do it the same way we could with the 30 degrees. I guess you could if you really wanted to, but that would be a nightmare. So instead, we're going to take that 2808 and we're going to multiply it by what? Pi over 180. All right, so I'm going to show you how to use the calculator correctly when you need exact answers. Now, we should be able to reduce this by hand, but we can use the calculator. So grab your calculator. My answer has to have a pi in it. I am not pushing the pi button, okay? So you're just going to do 2808 divided by 180, and then you can't forget to put the pi back on it. What are you going to get? Okay, so the calculator gives you 78 over 5, which means you get 78 pi over 5. This time we do not want any of the decimals. Decimals are junk here. Everything is an exact form. Fractions, improper fractions, and you got to put the pi back in. Okay, makes sense? So the biggest thing is, if you're going to use the calculator to help you, don't forget to put the pi back in. All right, so now to actually work this problem, how far, so we're looking for the arc length. That's equal to the radius, they're 8 feet from the center, which is 8, times theta, which is 78 pi over 5. So once again, we can use the calculator to our advantage, so I don't have to actually multiply 8 times 78, but I can't push the pi button, and I got to make sure I put it back in there. So 8 times 78 divided by 5. And your final answer would be what? What would it look like? Good. 624 pi over 5. And that is feet. And it's all one fraction. You don't ever take the fraction and just stick it next to a pi. Any questions at all on that? All right, so let's look at number 8. So it says the central angle theta in a circle of radius 6 meters has an intercepted arc length of 10 meters. Find the measure of theta. Okay, an intercepted arc length of 10 meters, that's equal to the radius, which is 6, times theta, which is what we're looking for. So I divide both sides by 6, and that's going to give me that theta equals 5/3. What are the units on here? Radians. It says find the measure of theta in radians and in degrees. We use the radian formula. This is 5/3 radians. I'm not missing a pi because there wasn't pi in my answer. Okay? Like, that is it. So then I also need it in degrees. So I'm going to take my radians, which is 5/3, and I'm going to multiply it by, since I want it, it's in radians and I want it in degrees, that's going to be 180 over pi. Okay. So you can take 5/3 times 180 in your calculator. And what do you get? 300. And then this is 300. Pi is still in the denominator. It's 300 over pi. This is my degrees. I need parentheses with the degree sign. If I don't have the parentheses, then I would only be putting the degree sign on the 300. Okay? So it's a weird looking angle to be in degrees, but it is what it is. I mean, Questions? Awesome.